Hello, welcome back to my channel. Today's topic is vertical circular motion or motion in a loop. The conditions required for an object to move in a complete circle, that is I am going to tell you, and hence the formula derived from this topic will be helpful for your board exams as well as for your JEE NEET and IIPMT exams also. As you can see, I have mentioned Puspa and physics. I think you are very much curious to know why I have written Puspa and physics, because while scrolling down my YouTube channel, I saw one reel on Puspara's song, that is from Puspa 2 movie, which is trending now. That dance step is called Chai step. While seeing that step, I saw that conditions for the vertical circular motion that is correctly fulfilled in this dance step, so that chai doesn't fall down to the ground, and the actor did it very perfect. If you have not seen this dance step, then go and watch. I'm also sharing this video again. I have shared two videos from that Puspara's song. One is real and another is reel from this song. Then at the end of the video, I will share why the real video where the actor Allu Arjun did it perfectly, and in the reel did it wrong. That I will be sharing with you. If you have watched this video, then I am going to explain what is the theory behind the chai step. Let's see. Let us consider one body which is tied to a string, such that one end of the string is fixed at the point O and the other end where the body is attached is free to move. Let us consider that I am applying some velocity or some force to this body such that it will move from this point to the point B. If you give very little force, then it may goes to this side, but it will not go to the point B also. That means if you give if you give a little force or little velocity to this body to go to this side, then it will go to this side and come back to the mean position, and again go to the opposite side and will come back to mean position. It will continue its motion like to and fro motion, and one time will happen comes that it will stop at the point A. That means that velocity is not sufficient at this point for this body to move to the point B or beyond B, so that it will not complete one circle. For that it is not completing one circle, and it comes back to the mean position, and it makes an oscillation, and that motion is known as oscillation. That to and fro motion is known as oscillation. This means that for a vertical circular motion we need some velocity, minimum velocity, which is called as critical velocity at that point during the motion of the object. This means that that much velocity is not sufficient for this body at this point, so that it is not covering one circle, or it is not going beyond B, or it is not going to the point C also. So we are requiring a minimum velocity, which is called as critical velocity at point B, so that it will go to that point B. If it acquires the minimum velocity at B, such that it will go beyond B and comes to the point C, then only it will make a complete circle. If it reaches the point C, then only it will comes to the point A again and makes a complete circle. So we are going to find out what are the minimum velocity at point A. so that it will go to the point B and C also, and will make one complete circle. We are going to find out the tension also, tension at A, tension at B, and tension at C. Like that you can find also tension at D also. So to find out the minimum velocity or the critical velocity at point A, B, C, D and everything, I am going to locate that object at the point P, so that is in between A and B. This point is at an angle theta from the mean position of the object. Here the object where the weight of the object is mg, and the weight vector has two components, mg cos theta, that is outward to the center, and here you can see the tension force which is towards the center. Since to move in a complete circle or in a circle, that body requires a centripetal force. That centripetal force will make that body to move in a circle. So the net force acting on this body during its motion at P will give the necessary centripetal force to that body. I mean to say that the tension force is acting towards the center, and another force, that weight force, which is always downward at the point P, and its components mg cos theta, that is away from the center. These two components or these two forces that is acted oppositely. That means the net force between these two forces, which is centripetal force, will be Tp minus mg cos theta. This Tp minus mg cos theta will give the necessary centripetal force for the body to move in a circle. At point P, as I have already told you that the centripetal force will be Tp minus mg cos theta. The net force acting towards the center is the centripetal force for the body to move in a circle. And as we know, if v is the velocity at point P, then mv square by r, where r is the center radius of the circle, then mv square by r will be the centripetal force. Here we get Tp equals to mv square by r plus mg cos theta. This is equation 1. From this equation we can find tension at point A, B and C also. Now at C, point C, which is the top point of the circle, if you see the free body diagram, then Fc is equal to the centripetal force acting towards the center is the weight force and the tension force on the string. These are both directed towards the center. So finally we got the result, Tc is equal to mv square by r minus mg. Since we are subtracting something from this to this, so the result will be minimum at point C. Again, we can calculate this tension at C through an angle. Since the point is at 180 degree from the mean position, so we can substitute the value of theta 180 degree in equation 1, and we will find that Tc will be this much. Now the important part is here. For completing one circle, the tension on the string at the point C, which is the top point of the circle, that should not be less than 0. It should be greater than equal to 0, because if the tension is equal to 0, then it already reaches to the point C and it acquires the velocity such that it will go in the forward direction and will complete the next half of the circle. But if it is less than 0, then the string will slack down or the object which is tied to that string, that will also be slapped down. That's why the tension should be greater than equal to 0. So substituting the value of Tc that is greater than equal to 0 from equation 1, we are finding this for the tension at C. So we are going to substitute this in equation Tc equals to mv square by r minus mg equation. So you will find Vc will be greater than equal to Rg, root over of Rg. This is the minimum velocity at the point C. Now at the point A, which is at the lowest point of the loop, the total mechanical energy. Total mechanical energy is the kinetic energy and potential energy, summation of kinetic energy and potential energy. Since the body is moving from point A to B, then it is going to C and D. The mean position is A, where the height of the body from the ground is taken to be 0. If the height is taken to be 0, then the potential energy of the body is 0. And if the velocity of the body at point A is Va, then total energy will be this much. Now at the point C, the total energy will be this much, because at point C the radius, the height of the body will be twice of the radius. So substituting the height of the body from the ground as 2r, you will get the total energy at point C is this much. Again, for minimum tension or minimum velocity, we found out that Vc is root over of Rg. Then Vc square is equal to Gr. And substituting all these, we will get the total energy at point C is equal to 5 by 2 mgr. Now, according to the conservation of mechanical energy or total energy, the total energy at point C will be equal to total energy at point A, which is always constant. So taking that part, Ta is equal to Tc, and substituting all the values from Ta and Tc, we will get Va means the velocity at point A should be greater than equal to 5gr. This is the minimum velocity at point A, so that the body will cover one circle and it will not slack and it will not fall down from the point C, and it will cover one circle completely. This will be the final formula for point A. This is root over of 5gr. Now the minimum tension at A, if you want to find the minimum tension at A, then substitute the value of Va in the equation 3. Might be equation 3. Yeah, this is equation 3. So after putting all this value, you will get Ta will be equals to 6 mg. This is the tension at the point A, so that it will move in a circle. As per the theory, you can easily tell me why that man holding that chai cup and that chai is coming towards the ground, and in the real video where the actor Allu Arjun did that step very perfectly. As you know, that chai is in the liquid form and the actor is holding that chai cup very tightly, but that chai which is in that chai cup has acquiring that minimum velocity at point A, B and C, such that it covers one complete circle. But in the real, that man is not giving that much velocity to that chai cup as well as to the chai, so that it is not acquiring that minimum or critical velocity at the point A, and it is not covering one circle, and that is falling down to the ground. For a quick review, I am writing all the formulas required for vertical circular motion for your better understanding. Remember all these formulas for the point A, B and C, such that it will be helpful for your board exams as well as for your entrance exam. Hope the combination of this entertainment, that is chai step, and the vertical circular motion from physics will be helpful for you to understand the content. Next, I'll be sharing some important units on this topic. Hope this help you. Thanks for watching.